Hey, Scott, this is Chris Logan, the curator's brother.
Hi, curator's brother, Miss Sandy.
Sandy, yep.
Yeah, yeah. So, hey, can you comment? I don't know if you know about the process of creating the Coors can that turned blue when it was the right.
Oh yeah, yeah, absolutely. The mountains turn blue when it gets cold. Matter of fact, this can is empty now, and it needs to be replaced with a full brother. So that ink is actually part of the decorating process. It's a real pain in the butt, Chris, to apply. If you look at the can at the left of this screen where it says "Born in the Rockies, Super Cold," so the company that makes the ink is a company known as INX, and basically we have to use a different sort of inker to fill to put that ink there, because the pigment vessels in that ink are bigger than than what would be in the red or the blacks or the grays. And it's almost, I don't want to say it's gritty, but if you were to look at it under a microscope, you could see more of a texture with it. Believe it or not, it's the same process as photo-gray glasses. So if you walk outside and your sunglasses got dark, it's the same concept, but instead of using light, they use temperature.
Interesting.
So that is the most expensive part of that can right there, is that photo or that thermal ink. Most inks cost between $7 and $10 a pound. So if you think about it, a pound of ink, our inks would come in 15 and 20 pound buckets.
Mm-hmm.
So the thermal ink would cost about $137 a pound.
Wow.
It's very expensive and a real pain in the butt to use. It's a really cool marketing thing. So you may remember a few years back, probably in the mid 2000s, like 2005, 2006 area, right about the time I went to Coors, they actually had a marketing campaign where they were specially lined for freshness. They called it the frost blue liner.
Uh-huh.
It was the exact same internal coating material. It just had food coloring in it.
Hmm.
And they had a banner across the top of the cans that, if you look in that 50th anniversary can there, it said frost brew lines for freshness. It was the same coating. It was just blue. Food coloring was added to it.
Neat.
Oh my gosh.
Thank you.
Yep, sure. That's a fun question. So it says, was BPA in the same? So I do know that BPA is still, or was, I haven't made a beer can since 2017. So BPA was a huge concern with that, and we were working with the coating manufacturer PPG to develop a BPA-free coating. So, and a lot of that was driven on the folks from California who recognized early on the potential health implications of using materials with BPA in them. So those are 3-piece cans there.
Already answered Patrick's question.
So, Coors would use both aluminum cans and the 3-piece can up until the early 70s. Matter of fact, the last 3-piece can to be filled at the Coors Brewery is in the family bar upstairs on the 6th floor of the brewery. So there you see Bill. The picture with him holding the can. Go back one, Kev.
Yep.
So the picture on the right is Bill Coors, where he was Metals Magazine's Man of the Year for inventing the aluminum can. And those cans on that chain in the background, those are actually on a pin chain. That pin chain is going through an oven to cure the ink on the can. The disc that Bill's holding in his left hand is what's known as a slug. The first cans were made using the impact extrusion process and not the drawing and ironing process that we use today. And the cans on the left there coming out of that oven were coated. That was a coating oven that they were getting cured in. So one of the reasons that Bill Coors wanted to use aluminum because it was infinitely recyclable, and they would go out and give people, a few pennies per every can, and using the cash for cans process. So a lot of people give Bill credit for being a environmentally, socially conscious human being who was concerned about the environment. No, that's not the case at all. He was concerned about saving money and came up with the aluminum idea to use it as a cheaper material. One of the benefits is it's infinitely recyclable, so that was kind of win-win for them. It's a lot easier to manufacture aluminum cans than it is for the steel cans. More cans. So these are cans going into the fillers. You'll see that they're single filed. It looks like those are filled already, so they're they're going into the packer before they're placed in the containers or in the packaging.
This was a slide I threw in, Scott. Just about.
Again?
I threw this in just to contrast the weight of the earliest used cans with the cans today, and they're basically the originals were 4 times as heavy or more.
Yes. So if you'll go back to that picture with the 50th anniversary can in it, Kevin.
Where am I going?
Back, keep going, keep going, keep going, and keep going. Oh, right there. Whoop. Not that far back.
Oh, there we go.
If you look at the can, just to the right, the one with the church key opening, yes, that one there. Dixie. That can is heavier than this 16-ounce can. The can sitting right next to it is a 16-ounce can. Those aluminum cans to the right and left are heavier than that can. And they only held 7 ounces.
Did you work in the Coors brewery for a short time as well? Not just.
I did. After 10 years at the can plant, they asked me to come up and run the packaging department's training up at the brewery. So I changed offices, went up there closer to the beer, which is great because I just had to get in the elevator to go to the family bar.
Nice.
And I did that for about 1.5 years.
Do you miss, I know you got a dream job in the automotive industry now with the new electric car you're working on. Do you miss beer cans?
I do. I'm a can maker. I absolutely loved everything about the process. As you alluded to earlier, my wife and my middle son are still can makers. It's nice that I can kind of help my wife troubleshoot quality defects from a distance. Matter of fact, my son will still send me a text message or give me a call if they're experiencing trouble on the manufacturing side of things,
Right.
quality defects, machines acting up, and I can give them some hints on how they could, where they should start troubleshooting at and trying to resolve those things. So, matter of fact, this morning, my wife chewed my ear off for about an hour about the night she had last night, and with some of the defects that they were experiencing.
How often would the whole line grind to a halt? You talk about these speeds that are just mind-blowing, like the number of cans you could produce in an hour. How often would the line just grind to a screeching halt, or was it not that often?
How long was that? The line, what, Kevin?
How often would it come to a screeching halt?
Actually, I would say somewhat regularly. When I first started the training department, the plant's overall equipment efficiency was 78%. We were able to justify our performance based on, or justify the need for a training department based on that performance. So after 5 years, we were able to improve our efficiency up to a little over 90%.
Mm-hmm.
But the factory equipment, manufacturing equipment is happier when it's moving. When it's cycling up and down and up and down, that's actually bad for the equipment. Plus, it also has the potential for creating additional quality defects. So when the line stopped, it would only be stopped for hopefully just a few moments, unless there was a catastrophic equipment failure, which would require an hour or so. But and typically that would be if the printers were down or some of the single, like a necker. The body makers, I had 20 of them on one line, and if I lost 2 of them and was running with 18, I could still keep up the pace.
Great. I want to know if there's any more questions out there.
Yeah, I have a question. It seems like in the past 10 or 20 years, like cans have gotten a lot more popular, and a lot of new breweries are just doing cans. Is that true, that cans are kind of getting more popular? And if that is true, do you see that trend continuing?
Well, absolutely. So one of the great things about cans are they're lightweight. The 10 grams is what a can will weigh after it's been printed and decorated and coated. They're so much easier to transport than bottles. They're easier to make than bottles. They're a lot more energy efficient than bottles, and they actually cool off more than bottles. So, yeah, it's that trend is still going to continue. Matter of fact, the 16-ounce cans, the network is starving for 16-ounce cans right now. I mean, they're sold months in advance. So anytime a factory that is configured to make 16-ounce cans has a shortage issue, it really just hurts the network, the supply, and it just things that just awful, absolutely awful. So the button top cans, yes, Scott and Helene, is that it? The button top cans were made at the Rocky Mountain Metal Container End Plant in Golden, Colorado for a limited period of time. I remember them because I thought they were cool. You could just use a little button to push those buttons and everything, but they had to stop them because people were cutting their fingers. You know, and just like Jimmy Buffett, if you guys remember back in the day when they had the ring pull cans, you know, you step on a pop top, that is no good. And it was kind of the same concept. The bottom of the can, where the dome is, and the lid are the thickest parts of the can, and they are extremely razor sharp. Let's see, how much to produce a bottle? Whoa, probably going to say, depending on if they get cullet or not, I'm probably about 13 cents per bottle. And then for I work for Lucid Motors. Lucid Motors is a luxury electric vehicle company. We're building our factory here in Casa Grande, Arizona. We are going to be deploying the Lucid Air, which is going to have its world debut on September 9th. But if you're interested, you can go to YouTube and look up the Lucid Air, and it has lots of cool pictures and videos of speed tests that we were doing, and then things like that. It's a wonderfully fascinating contest. So aluminum bottles, let's talk about those. It's a 16-ounce can that's, instead of being necked 11 times, it's necked 33 times. But it's the exact same process, a little bit thicker metal because the neck at the top is converted a little bit more, especially with the screw put on there. Those actually cost 25 cents a piece to make. That's an impact extruded bottle. I was talking more about the ones that Miller Lite and Coors come in. It's an actual can. But that's fascinating, Kevin, because that bottle, that aluminum bottle you had there, same process of the original beer cans, that impact extrusion. Okay. Let's see.
Did you get all the questions?
I think so.
Well, I want to personally thank you, Scott, for all your support of my little humble museum over the years.
It's been a pleasure.
It's exciting. I have a special exhibit just for the onset of aluminum in the beer can world, and the things that you sent are just wonderful. So thanks for joining us tonight, and I hope you can stick around for